Since childhood, we know that we have exactly 10 fingers, and any preschooler can count to 10. In adulthood, we rarely given a thought on how we count. For the sake of studying computer science, we have to dig deeper. Let's take a 10 usual eggs and count. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. But wait, why are all the other numbers are having one digit and only 10 has two? What's wrong with this number? We've known it since childhood. Let's pour some tea and think. We've counted the first 9 items with numbers in which there is only one digit, from 1 to 9. But as soon we need to count the 10th item, a 2-digit number appears. Why is it so? Wouldn't it be more logical to have a separate number for describing 10, since we have 10 fingers? In fact, they already tried to do this, but nothing good came out of it. In ancient Rome, 2000 years ago, a system of writing numbers using letters like I, V, X, C was used and there was a separate letter X for the number 10. In Roman system, you will quickly notice the problem. Such a notation quickly becomes unwieldy. For example, here's the number of 1988. Since you cannot put more than 3 identical letters in a row, the maximum number that can be written in Roman numerals is 3999. To write larger numbers, the Romans got it this way. The dash above the letter meant 1000. The letter V with a dash meant 5000. Ways were also found to write common fractions, such as 1/2, 1/6, 1/12, but it was still inconvenient. Arabic or Indian notation, using numbers from 0 to 9, was much more convenient. The main difference from the Roman and the great scientific achievement of the Arabic system was the introduction of number 0, which meant nothing. The Romans didn't even have the idea of having number to represent nothing. In the Roman system, a letter always meant the same number. X always meant 10, wherever it was written. But the number 0, if attributed to the right of any number, increased it 10 times. Thus, it was possible to write down 10, and 100, and 1,000, and 1,000,000, that is a million, and 1,000,000,000, that is a billion. It is easy to see. The more to the left the number are, the greater their weight. Each digit to the left denotes a number 10 times greater than the one on the right. Such a system of numeration is called positional, because the digits in different positions denote different numbers. The number in the position on the right are called ones. A little to the left, tens, even more to the left, hundreds, thousands, and so on. If there is only one digit, we say one-digit number. If two, two-digit number, three, three-digit number, and so on. Sometimes they say, his salary is a six-figure number, which means we are talking about hundreds of thousands. Let's take eggs again and show an example. At first, we have nothing. 0 eggs, 0 ones. We add one unit at a time. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then the digits are over. We don't have digit more than 9. This is how the first 10 appears. We count further. 11, 12, 13, and so on. we close the second 10. Now let's count in tens. 10, 20, 30, 40, 50, 60, 70, 80, 90, and the 100. You could say that every time we run out of small boxes, we need a box 10 times bigger. Let's say you have 3 large boxes of eggs, 2 small boxes, and also 5 eggs in your store. You will say 325 and write down it briefly with 3 digits. Each is one located in its old position. Let's number those digits. On the right is the zeros digit, then on the first, second, and so on. 3 times 100, 2 times 10, and 5 times 1. The sum is 325. It can be easily seen that any number is equal to such a sum. The number in one place is multiplied by 10 to the power of 0, plus the number in tens place multiplied by 10 in the power of 1, plus the number in the hundreds place is multiplied by the 10 to the power of 2, and so on. This is very important to understand. Understanding how number is obtained from digits will allow us to work with any other numerical system, not just decimal. From here, it will be easy to understand how to switch to the binary number system, which is used in computer technology. So, the way we count is called a numeral system. Every day we use the decimal, positional numeral system. Decimal because we only use 10 digits. Probably only 10 because we have only 10 fingers. This system is called positional because the digit standing in different position denotes different numbers. The further to the left number is, the more it weighs. Each position is 10 times greater to the previous one. In everyday life, we do not count from 0. Rather we say first, second. But when studying computer science, you will have to get used to the fact that the count starts from 0. 0th, first, second. Also, for example, in some countries the first floor is called 0th floor. So, for some cultures, it's natural to start counting from 0. Second note. Any number to the first power is equal to itself. That is, 10 to the first power is 10. But 10 to the power of 0 is 1. Surely you will find a lot of videos on YouTube explaining why it is so. Just remember, any number to the power of 0 is 1. Such is mathematics.